Hey everyone, welcome back to Scalar. So today in this particular video, we are going to talk about RAG, Retrieval Augmented Generation. But before we get started, don't forget to subscribe to our channel so you don't miss the rest of the Agentic AI series. And if you are serious about building your career in AI, then do check out Scalar's Advanced AI and Machine Learning program, co-certified by IIT Roorkee CEC. It's designed to help you master the skill needed for the real-world AI role. The link is in the description box. Also tell us in the comment what other AI topics you would like us to cover. So let's get started.
So let's first talk about what exactly is RAG. RAG stands for Retrieval Augmentation or Augmented Generation. Now, as I've already explained this in a second video, but those of you who are directly looking into this video, for them, I will again go into the detail of what exactly RAG is. For those who want to skip this part and directly want to jump into the component of RAG, the very first component, which is text splitter, you can fast forward this video or directly jump to that timestamp. But for those who are directly coming to this video, I will request all of them to please listen very carefully, because conceptual understanding of RAG is very important, and this is also a very frequent interview asked question. So your LLM, which is basically the artificial brain, can now answer your questions, right? So if you ask this LLM, who is the PM of India, your LLM will be able to answer this question. If you ask this LLM to write a story about you, maybe about India or maybe about a Indian boy, it will be able to ask this or answer this question. So LLM, which has been trained on a general data, on the huge amount of the open source internet data, will be able to answer your general queries and will be able to understand your queries also. But there is one potential problem with LLM. The problem is that LLM is not aware about your data, about your context, about your knowledge base. So let's say if I have a document, and this document is a contract which I'm signing with a company. So this is a confidential contract which I'm going to sign with the company. Now I want my LLM to answer me the questions based on this contract. And my LLM, since it is not aware about the content of this contract, will not be able to answer my question. So if I ask my LLM, maybe what's the age of the contract? Now, when you provide this question to your LLM will immediately ask you, can you provide me with the contract? And if you want to provide your LLM with a contract or with a external document, you need to load or provide this entire PDF or maybe entire text to this LLM. Now the problem is that this contract itself is a huge document, is a huge document. And given that the LLM is limited to a context window, so your LLM has a limited context window. Your LLM cannot understand or cannot digest or cannot process huge documents. If you provide your LLM with this small question, with this huge document, let's say you upload this entire document in ChatGPT or in Gemini, the problem is that these LLMs has limited context window. So they will make error. They might end up giving you wrong answer. So number one problem is that there is a limited context window, limited context window, which makes it difficult to upload huge documents. I can upload a document with, let's say, 10 pages, but what if I have the entire book? What if I have a book of 400 pages? Can I upload that in ChatGPT? Can I upload that in Gemini? Possibly not, right? So, one problem is that it has a limited context window. Second problem is that it will take a lot of time to process, and the chances of making error is also high. So, error with high processing time, right? So these are the two potential problems, and the industry was acknowledging this problem. They wanted to create this kind of question answer chatbot, but they also want to make sure that this chatbot is also aware about the context regarding their company, about the context regarding their database, about the context regarding their products. So for example, if let's take example of Amazon. So if Amazon wants to come up with a chatbot that can answer generalized questions based on the query of a user, Amazon has to make sure that this chatbot is a very good LLM. When I say LLM, I'm right now referring to a brain, artificial brain. So this chatbot needs to have a good artificial brain, which basically mean this chatbot has the capabilities of natural language understanding. Also, this chatbot has a capability of the text generation. And this text generation is not a random text generation. It is based on the semantics, which basically means this is based on the context learning. So, this text generation is based on what the user has asked for. This is contextual text generation. It is not a random text generation. And we all know that these kind of capabilities are now available with LLM. So we do not have to worry about developing this kind of another model. We have the LLM available with us. Now, all we need to do is we need to provide this chatbot with the knowledge base. Now, this knowledge base will help the chatbot to optimize or to make sure that this chatbot is not answering the questions based on the general knowledge that it was trained on. This chatbot is able to answer the question based on the knowledge of your company, based on the constraint of your company. So, this kind of application requires the concept of RAG. Now, RAG has two very important entire name, which is Retrieval Augmented Generation, has three words. Retrieval is a component, augmentation is a component, and then generation is a component. So when I say component, I basically mean there are three important stages of the entire RAG application. So now let's try to understand what exactly RAG is. I hope you guys understood the entire problem. Now, once we have understood the problem, let's understand how RAG solved this problem. So, when we talk about RAG, let's understand the general framework first of all, how the general framework will look like. So, I will have some data with me. Let's assume that this is a PDF file as of now. So, this is a PDF file with some, let's say, 10 pages. Now, I first of all need a component which can help me load this particular PDF file or the pages of this particular PDF file into my RAM. So I want to load this entire page, or let's not. So let's say this entire page has to be loaded in my memory, which is RAM. So here we need some kind of component which can facilitate this process. And this is where I need some kind of document loader. What is document loader? I will talk about that very quickly. But please understand the process that if you have some external document, if you have some external, let's say, data, your knowledge base, you want to load that data into RAM or your application. And this process requires some kind of code, some kind of component, some kind of code component to facilitate this process. That is where the document loader component comes into picture. So once we have this particular document, which is your PDF loaded into the RAM, I cannot provide the entire PDF to my LLM. Again, because of the problem of context window. So there is a limited context window. And if you provide the entire PDF, there are high chances that your LLM might do a major mistake in answering your question. So we need to somehow limit the context. So what we will do, we will split this entire PDF into multiple chunks. And how this process of splitting will happen, there are multiple techniques that we will talk about. But what we are essentially going to do is we are going to split the entire page or entire PDF into multiple chunks. And in order to facilitate this in your Langchain, we have what is known as the text splitters. So text splitters will basically facilitate the process of splitting your document into multiple chunks so that it becomes digestible by your LLM. Now, once you have converted that PDF into chunk or the document into a chunk, you want to convert these pages into their mathematical representation or the numerical representation. So I want to convert this page into a vector, and this vector is nothing but some numbers, but these numbers are not random. These numbers are capturing the semantic meaning of this entire chunk. So please remember, I am referring to this chunk C1, C2, and C3. Now, how exactly a chunk is generated from a PDF, we will talk about it. But chunk is a group of words or sentences, which is the part of your PDF. But you cannot preserve this particular PDF as it is in your memory. You can preserve it, but the reason we are converting this chunk into a vector numerical representation is because I want to perform a semantic search. Now, why I want to perform a semantic search, we'll talk about it, but the process of converting a particular page or a chunk into a vector is known as creating embeddings. So these are known as your embeddings. And right now, this is known as a document embedding or the chunk embedding. And this embedding is nothing but a group of numbers. And these numbers are capturing the semantic meaning of the entire chunk. So these are not random numbers. Now, once I have done that, so again, in order to facilitate this process of converting chunk to embeddings, we need some embedding models. So those models that can convert your chunk, which is text data, into numerical data, which are basically embeddings or vectors. So we need embedding models. Once this is done, I want to preserve all these vectors or embeddings into some kind of database. So this is basically the final location where I want to preserve all these vectors. Now, since here I'm preserving the vector, this is known as a vector database. vector database. Now, this is one workflow where I have loaded my PDF into the system, which is your RAM. We splitted the entire PDF into multiple chunks. Then we converted all these chunks into representative numerical values, which are known as the vectors or the embeddings. And finally, we preserved them in a vector database. It is a database which can hold your vectors. Now, the second part of the RAG application will come into picture now. So let's say this is the user. Now user will ask a question. So this is a question or the query. So let's say the query is, what's the age of the contract? Now what we will do is, in order to answer this question, I need to first of all find out the relevant chunk which might have the answer to this question from our PDF. So I want to, or before I can provide this question to my LLM, so I will convert this question into embeddings. Again, here I will have some embeddings. Now I will take this embedding to my vector database and will search or will perform the semantic search. So this embedding, let's call it as EQ because this is the embedding of the query, will go in the vector database where I have the embeddings of all the chunks. And now this is basically a process where the retriever will play the role. So retriever over here will basically facilitate this entire process. It will first of all take the query from the user, will generate the embedding corresponding to this query, will take this query, the embedding corresponding to the query will be taken into the vector database where the semantic search will be performed. And semantic search basically mean which of the chunks is most similar to this particular query. So which particular chunk might have the answer to this particular query or question. And this retriever will facilitate this entire process. The retriever will return the chunk, not the vector, the chunk. So let's call that C2 is the chunk. So it will return the text related to the chunk which has got the highest similarity match with the query of the user. And now I hope you guys are able to understand why it was important for us to convert all these chunks into representative number so that we can perform the similarity matching, which is the semantic search. So semantic search cannot be performed until and unless you convert these chunks into some representative numbers. And that is the reason we have done that. Now, once we have this chunk, which is the text available with us, given that this particular chunk has potentially the answer to the user's query, this chunk and this query. So I'm writing it as Q and this is C2. So this Q and C2 will generate the final prompt. So this is my final prompt. Final prompt. And now this final prompt will go inside the LLM, which will answer my question. So I will get the answer. Now this is what this entire flow that you have taken. Let me just zoom out a little bit. This entire flow that we have looked at is what RAG applications are. Now, what is retrieval? So here we are retrieving. Here we have retrieved. So here, let me change the color. So here we have performed the task retrieval. Retrieval. Now, what is augmentation? This is where we are augmenting the query of the user. So augmentation. And then this is where the generation is happening. So the name RAG basically has three very important stages. Retrieval, where we are trying to fetch the document which is similar, or the chunk which is similar to the user's query. Then we are augmenting that document or the chunk with the user's query, and that augmented prompt goes inside your LLM to answer the question. So this is what we are going to learn in the next two videos. Now in this video, we will talk about number one, what are the various document loaders available to us? So from which all sources I can pull out the document or the text into our system. And then what are the various ways available to us to split the document which we have loaded into small and small chunks. Now, before I start, I'll explain one thing. When we talk about document loader, which is the first component, you can acknowledge that the data which is available with us can be in the form of a PDF, can be in a form of a CSV file, can be in a form of a web page, can be in a form of a code. So I hope you will acknowledge that the source of these documents can be multiple. So let's say these are the source of all the documents that we possibly want to load inside the system. So let's say this is my PDF. Let's say this is a normal text file, TXT. This is a CSV file. This is a web page, so HTML. So all these are basically the sources from where I want to possibly load the data or the textual knowledge into my LLM. Now, you need a system which can facilitate this process, and that is where over here our document loader comes into picture. So this is my document loader. So document loader is a component in Langchain which helps the process of getting the document from a particular source and loading it into the system in a form which can be understood and processed by other LangChain components. So when it loads this document from PDF source, the output is always a data object which is known as the document. So remember this very important thing. Those of you who already know about Python, I hope you will acknowledge that when you load a CSV file into pandas, the pandas library. So when you load a CSV file into pandas library, it will be loaded as a data frame. When you load a Excel file, it is again going to be loaded as a data frame. So you have multiple load functions available, right? You have pd.read underscore CSV, you have pd.read underscore Excel, you have pd.read underscore HTML. You can read from JSON, you can read from XML, you can read from SAS, you can read from Stata. So there are multiple functions which Pandas provides you to get your data data into the data frame. So data frame is basically that data object or the container which is provided by pandas to facilitate the process of data analysis. So if you want to perform data analysis in pandas, you have to load your data into pandas data frame. Similarly, the document loader component which we have in LangChain will provide you with multiple functions to facilitate the process of loading the data into the document data object. So the document that I have written over here is basically the data object of Langchain document loader. Document loader. Now, once you have the data in the document data object, you can do anything with it. So, a document data object in Langchain comes with two components. One is the metadata, and other one is the your page content. Page content. So we will look into it. I'll show you this. But as of now, I hope you guys are clear with this. So now let's talk about the concept of text splitters. You might be wondering why we need text splitters. So I hope you remember that we just got the HTML data or HTML content from the Wikipedia page. So what we did was, this was my Wikipedia page. We used the web base web base loader to get the HTML content into the document object. Now what we did, we provided this entire document with the question. So I'll just say with the question or the query, and we created a dynamic prompt to my LLM to return me the answer. So this is what we did. But the problem is that the LLM has a limited context window. Also, the problem is that you are going to consume high amount of tokens when you want to get your answer from the LLM. And also, we acknowledge the fact that the entire document is not useful to answer a question. So, for example, the question which we asked was when Mr. Modi became the first time CM. And I hope you will acknowledge that this particular answer will be available in a very specific portion or the chunk of the entire document. So that basically means I don't need to provide the entire document to my LLM because it is useless and it is just taking away the computational power of my LLM, also consuming a lot of tokens which will cost us. So scientists thought about it and they created the concept of splitting the text or the entire document into smaller chunks. Now, the very first advantage of doing this is that you get those chunks or smaller chunks which are manageable and which can be easily consumed and processed by the LLM. So, what we will do now, which is the path that we are going to follow, once we have the document ready, I am going to use the another component of my RAG framework, which is text splitters. Now, what these text splitters will do, it will basically split your document into smaller chunks. So you might get, let's say, C1, chunk number one, chunk number two, chunk number three. And these chunks are now in a compact format, which can be provided to the LLM for basically the context based answering. I'm not providing the entire book, I'm just providing a specific part of the book to the LLM to answer my query. For example, if you go to the teacher and ask that you have problem in maths, but if you go to the same teacher with a specific question and you tell that teacher, I have a problem in this question, you will get the right answer or you will get a satisfactory answer to your problem. Whereas if you just go to the teacher and you will say that I have a problem in maths, the teacher will not be able to help you because the teacher is unaware about the context, unaware about what exactly is your problem, in which particular topic of the mathematics you have the problem. So by creating smaller chunks, you are reducing the context, and your answers which will be generated by the LLM will be more profound, which will be more correct, and the hallucination, the problem of hallucination, the problem will be resolved. So by doing this, you are actually increasing the quality of the answers that you will generate. Now this process of creating a chunk out of a document is basically what is done by the text splitter component of your Langchain. So text splitter is one of the component of the Langchain which facilitate the process of splitting a document into multiple chunks. Now to split the particular document into multiple chunks, we have multiple methods also. First method is known as the length base. Based on the number of words, we divide. I will teach you about this. We have based on the structure of the document also, a structure of document, and we have based on the semantic meaning also, semantic meaning. So these are basically the logical way of splitting your document into smaller chunks. How exactly this is done, I will explain you, but I hope you are able to understand the background and the requirement. There is also one more advantage of these text splitters, which you will be able to understand when you move to this part in the RAG pipeline. If you try to create the embeddings of the entire document, the quality of the embeddings are found to be very bad. So let's say once I have loaded this entire PDF over here, once I have loaded this PDF into my RAM, and if I want to create the embedding, so let's say if I remove this particular part, if I don't do this, if I just directly jump to this part, so if I create the embeddings of this entire document or the entire PDF, the problem is that when you try to compress the contextual meaning of the entire PDF into some vectors, the quality of these embeddings will be very bad. And if you take this intermediate step of creating chunks, the quality of the embeddings would be very good. And hence, your retriever will be able to better serve you with the respective chunk that might have the answer to your question. So, by doing this process of text splitting, you are not only consuming less tokens by providing a very specific context to your LLM, but also you are increasing the power of the retriever by making sure that you have good embeddings of smaller chunks available in your vector database. So these are the two advantages. The reason I have explained you this in a much detail is because this is a very important interview question which people generally ask regarding why we need text splitters when we can directly provide the entire PDF to the LLM. And I hope now you have the very good answer. But now let's directly jump and into the code, into the notebook, and let's try to understand how to perform length based text splitting, then how to perform structure based, and finally the semantic based. So now let's talk about the length based text splitter. The text splitters are available in a different package. So this is basically available in Langchain hyphen text hyphen splitters. So you have to load this package also. And then we can start with from Langchain underscore text underscore splitters. I want to import the character text splitter. Now we will create the splitter object. Splitter object will be the character text splitter. Separator, I'm keeping a space. Chunk size is 100. Chunk overlap is, let's say, 0. And I close the bracket. Now what I'm going to do is, let me take the text loader to load the text. So I'm just going to copy this piece of code over here. Additionally, I will copy this piece of code. So this will basically load my text file. And now I'm going to perform the splitting of this document. I hope you guys remember document is a list. So you have to instantiate or maybe index it. Then you can find the content using page underscore content. So I want to split this now. So how I will do it? I'll just take the splitter object and I'll just say dot split text, and I want to split this entirely. This is my text that I want to split. Now this is splitted. How it has splitted? So let's try to now understand this in a very beautiful manner by using this website. So here we are using character splitter. Let's keep the chunk size. What was the chunk size I used? Over 100, but let's keep a chunk size of 10 with chunk overlap of 0. Now I'll explain you what is chunk overlap, but let's try to focus on the result. What it is doing is essentially simply counting the 10 characters and making it as a particular chunk. So my first chunk is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is one chunk. Then another chunk starts from here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then another chunk starts from here and so on. So this is what the character splitter is essentially doing. It is just counting the number of characters which you specify over here, and it creates a chunk at that particular point. Now here we have defined 100, so it is basically counting 100 characters. So you can see that since this was my entire text, it has counted 100 characters and it has made a split. Then here it is another split, and so on. Now if I keep overlap of, let's say, one character, or let's say 5 characters, what essentially is happening is that now the chunk number 1 and chunk number 2 will share some of the characters in common. And the reason this is done is to make sure that if the splitting is happening abruptly, for example, over here it is abrupt split because born September, and then the main text is available over here 17, 1950. So when the text is splitting abruptly, your chunk overlap might do a justice by making sure that some part of the next text is available in the previous text. Let me show you the result by doing it, making this as 10. And now what I'll do is I'll create another object. Let's do it here itself. So now you can see here we have September, here also we have September. So now you can see that by using this overlap, we have somehow solved the problem of abrupt ending. So by sharing some characters between two chunks, but this is also not very good. The problem is that this is not logical because you are abruptly cutting out a text in between the words, which factually and logically will not make any sense. And for the LLM, it might become very difficult for getting you the answer from such splitting, right? So generally people don't use this kind of character text splitter because this is very simple. It's based on a very simple logic, but it is not very useful. The text splitter that is very much useful is known as the recursive text splitter. Now, recursive text splitter uses the concept of splitting the text based on the structure of the document. So now let me go back to my iPad to help you understand the recursive text splitter. The recursive text splitter is basically a splitter which is based on the structure of the document. Now, what it will do is whenever you create a document, you create it based on some words, some delimiters, then some lines, some paragraphs. This is basically the structure you follow logically to create a document or to create let's say a text. Recursive text splitter also tries to follow the same structure. It will not break on a particular character, it will not break on a particular line, it will follow a hierarchy, and you need to define the hierarchy. So let's say I have defined the hierarchy as first split it on, so this is paragraph, then split on a line, then split on, let's say, a dot, then split on, let's say, exclamatory mark, then split on, let's say, a space, and then split on a character. So this is the hierarchy that we have defined. Now what will happen? So let's say the document consists of my name is Sumit Shukla. I am from Kanpur. Now let's quickly count the number of characters in each of the line. Let's say these are the two lines, and this is my entire document. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 over here. Let's say I have defined that my chunk size needs to be 10. So here what it will try to do, it will try to check that if it goes with a paragraph, so paragraph is not available, so this option is not valid. But it will, if it goes with a line split, can it maintain the chunk size of 10 and 10? So since splitting out a line, so first it will split it on a new line. A new line will give me one chunk as my name is Sumit Shukla, and another line will give me I am from Kanpur. Now both of these chunks are not sufficient enough to call or to be called as a chunk because none of them is following the chunk size of 10. So that means after splitting it on a new line, which is level 1, now it will try to split on a dot. I don't have a dot. Now it will split on a exclamatory mark. I don't have exclamatory mark. That means now it will go and try to split out on a space, which means it will do the chunking based on the words. So now after this document or this chunk will be further broken down into my name is Sumit and Shukla. And this will be broken down into I am from Kanpur. Now let's count the number of words. So here I have 1, 2. Here I have 1, 2, 3, 4. Here I have 1, 2. Here I have 1, 2, 3, 4. 4 and 5. Here I have 1, 2, 3, 4, 5, 6. Here I have 1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, I think 2, 2, 4, 6. Now it will not stop over here. Since it is recursive, now it will try to make sure that a chunk is able to reach to the specified chunk size, which basically mean now it will start combining. So it will see, can I combine my and name to reach closer and closer to the specified chunk size. So if you combine my and name to become a one chunk, now the total number of words are 4 plus 2, which is 6 plus 1 for a space, so 7. So now it is 7. Now it will try to check, can it also further combine one more word. So what if it goes with this? So can it combine is also? So if it combines my name is, so 7 plus 2 is 9 plus 1 for space, so it is 10. Now this will be my one final chunk. This is chunk number 1. Now it will do the same thing with the next one. It will see, can it combine Sumit and Shukla together. Sumit and Shukla when combined will become 11, which is not correct. So it will not perform this. It will go back and it will say, Sumit is your another chunk and Shukla is your another chunk. So this is done. So this chunk is created. This chunk is also created. Now it will go and it will go to the next basically line. It will see, can it combine I and M. I and M can when combined will create 1 plus 2 is 3 plus 1 for space, so 4 characters. So it is 4 over here. Now it will check whether it can combine from also. So when from is combined, it will be 4 plus 4 8 plus 1 for space, so 9. So I am from will be one chunk with 9 characters. Again, this cannot be further exceeded because 9 plus 6 will not be, will giving me 15, which is crossing the limit. So this will be one chunk and another chunk would be Kanpur. Kanpur. So this is another chunk. So this is how recursive text splitter will work. It will recursively perform the task and it will it will go with a logical step. It will start from the paragraph split, line split, delimiter split based on, let's say, full stop or let's say exclamatory mark or question mark, finally on words and finally on characters. So this is how it will happen. Now if you fine tune it a little bit, if you put the correct chunk size and if you put the correct series of the delimiters, believe me, recursive text splitter can do a very good job in your RAG application. So learning about recursive text splitter is a plus point, and knowing how to optimize it is like a cherry on top of a cake. So if you have understood it, it is very good, but I would still recommend you to spend more time understanding about how to optimize this, finding out the best chunk size and finding out the best splitter delimiters for your specific documents. Now let's implement this. So let's try to perform the same split using recursive text splitter. So from Langchain underscore text underscore splitters, I want to import the recursive text splitter, recursive character text splitter. Let's create the chunk size of 100. I want to use the length function as len. So this is optional, but len means I'm basically doing it on length. As you have seen in the demonstration also that I was counting the number of characters. So length. Chunk overlap is not so significant over here, so you can ignore this part. What is important is separators. So I need to specify separators. So my separators are, I want to start with the paragraph, so /n/n. Then I want to go in a new line, so /n. Then I want to go with a dot. Then I want to go with a question mark. Then I want to go with the exclamatory mark. Then I want to go with a word, so space, and finally on a character, so nothing. And that's it. Let's create the chunk. So chunk is equal to a splitter dot split underscore text and this document. There is a problem. Okay. By default, the chunk overlap is designated as 200. So if you don't want to use chunk overlap, you have to specify it. So this is a default parameter which I have to overwrite. So chunk overlap, I'm keeping it as 0. I don't want overlap. And now let me see the chunk. Now if you look, you will find out a structure. You can see that now it is not broken at an abrupt point. It is getting broken at a very decent point, which is completing the text. So this is the advantage of your recursive text splitter. And I hope you guys are able to understand the recursive text splitter. Now, together with this, we have basically one particular splitter, which is your the semantic meaning splitter. The reason I'm not going to teach you about the semantic meaning splitter is because as of now it is in an experimental stage, and even you will not find the support of that splitter in Langchain text splitter. The semantic text splitter is available in your Langchain experimental library. So I am just typing the name. You guys can go and search for it. What is semantic based splitter? Semantic meaning based splitter. So what is happening is when you have particular document which is talking about multiple topics. So let's say you have a document which was first talking about the concept of, let's say, linear regression. Then you had another page which started talking about, let's say, the concept of KNN. Then you have another page which started talking about the concept of decision trees. Now, logically, all of them are related to the concept of machine learning. But if you look at them, you will understand that each of them are different from other. If I'm asking you what is the optimization function of linear regression, I'm specifically talking about it. But there is no point of keeping any text which is common between this and this. There should not be a common text between this and this. So when I want to split it, I want to split it in a way that this particular entire text related to linear regression is well separated from the text of Canaan. This is one example, but another example that you will be able to relate it is, let's say I have one document talking about health, other document talking about, let's say, stock market. And let's say these two PDFs are in the same folder. So when you load them, it will be loaded all together. Now, semantic meaning based splitter, what it will do, it will try to split your documents in a way that it is following the semantic meaning. So it will try to find out, our spelling is wrong. So it will try to find out which particular document is talking about one particular topic and which particular document is talking about another topic, and it will try to split it based on that. Semantic meaning based splitters are not so much useful. I would not say useful, they are useful, but they are not so much powerful as of now. That is the reason Langchain has not kept it in Langchain text splitter library. It is the part of Langchain experimental, where this right now this has been considered as an experimental phase. So I hope now you guys are like ready to talk about or maybe read about this also. But I hope in nutshell you are able to understand the broad concept of splitters. And again, this is not a topic that I will be able to complete in a video, but I will always suggest all of you to read the document, because whatsoever I'm teaching you is coming from the document. So please read the document to get a better understanding about all the document loaders and text splitters. So here, if you click, you will get all the text splitters that you want to read about, and it will give you a detailed explanation of all the topics. You will be able to understand everything, and it is very simple to read. So that is all about from my side for this particular video. This was a long video, I understand, but since we are going to develop something very exciting and very powerful by the next two videos, it is important for us to cover up all the core concepts. And I hope I did justice in covering up these core concepts both theoretically and practically. If you like this video, don't forget to mention your comments. I really appreciate when you write some comments and when you give me feedbacks, and it really helps me and the entire team to optimize the video creation process. Also, if you have any question, please mention it in the comment section. Don't forget to share this video with your friends who are looking to upskill in the generative AI field, and keep following our channel Scalar.